Hello, welcome to another micro tutoring session from Prep Plus. Prep Plus micro tutoring sessions unlock the secrets to common math and physics exam and homework problems. Today's problem is an exercise in integration by substitution. So this is a calculus topic. So let's just get right down to it. Let's say you're given a problem to calculate the following integral. And let's just call this integral I, just for the sake of argument. Calculate the integral I over the entire x-axis from minus infinity to plus infinity of the quantity e to the minus alpha x squared dx, where alpha is just some constant, some positive constant. So once again, we're going to calculate the integral from minus infinity to plus infinity of e to the minus alpha x squared dx, where alpha is just some positive constant. So you look at this thing and maybe the first thing that comes into your mind is to use integration by parts. You should try to verify this for yourself. Integration by parts will get you nowhere, but go ahead and try it and see what happens. So it turns out this integral cannot be calculated by conventional methods, so we have to be a little more creative. So let's just take a look at the exponent, and we see the exponent has an x squared in it. So what is going on with that? What can we make out of that? So let's draw an xy, a little picture, y, x squared. What does that make me think of? So that sort of makes me think of a radius of a circle, because the radius of a circle is radius squared equals x squared plus y squared. So if you have a point on the circle, x, y, and that's the radius to that point, that radius, let's call it rho, it turns out rho squared is x squared plus y squared. Okay, so if we can make this x squared sort of become an x squared plus y squared, that might be helpful. So let's just try to do that. So let's just write down our integral once again. The integral over the entire x-axis from minus infinity to plus infinity, e to the minus alpha x squared dx. Okay, so just from that little sidebar a second ago, x squared plus y squared is kind of what it would be nice to have in the exponent. So let's just rewrite that, see what happens. Times minus infinity to plus infinity, e to the minus alpha y squared dy. Okay, so now we look at this and we see this is pretty much, or this actually is, just the square of what we're looking for. So we're going to call this I squared. Okay, so now let's just rearrange this. Remember, when you've got multiple integrals, you can rearrange things if that helps to simplify the problem. So let's just go ahead and do that. So this is the integral from minus infinity to plus infinity, and let's do it again, minus infinity to plus infinity, e to the minus alpha quantity x squared plus y squared. There we go. dx and dy. Okay, so now I think we're kind of getting somewhere. Now we've written, we started off with I. Now I squared is the integral over the entire x-axis and the integral over the entire y-axis of e to the minus alpha x squared plus y squared. And that's kind of what we were looking for. So now, following the sort of side hint that we were looking at a minute ago, this reminds us of polar coordinates, a radius and an angle. So let's just transform this integration into polar coordinates. Okay, so let's just go up here. I squared is So now the entire range of phi, the polar phi angle is 0 to 2 pi radians, 0 to 2 pi, and the entire range or domain of the radius is 0 to infinity, so that would be 0 to infinity of e to the minus alpha, okay, x squared plus y squared is the radius squared, rho squared. This is an element of area, so the element of area in polar coordinates is rho d phi. Rho d phi. You just need to know that. Okay, so let's just go ahead and keep chugging away. The integral over the polar angle phi, so 0 to 2 pi of d phi, well, that's just 2 pi. So that's 2 pi. Now we have an integral from 0 to plus infinity e to the minus alpha rho squared, rho d rho. Okay, so now let's just do a reality check. We started off with an integral from minus infinity to plus infinity. At this point, and that's called the integral I, now we have an integral I squared that's from 0 to plus infinity. So instead of being from minus infinity to plus infinity, it's from 0 to plus infinity. So at least we've cut the domain of integration in half. So that seems like it might be a good thing. It's certainly reducing the complexity of the problem. So that's a good thing. So let's just keep going. So now this is where we do the substitution, the calculus substitution bit. So we look at this and we say, all right, let's just make the substitution S is minus rho squared. That's our substitution. Let's make that a little bigger. S is minus rho squared. Okay, so that means ds is minus 2 rho d rho. Okay, so our substitution, this is our calculus substitution trick. Substitute s equals minus rho squared. That means the differential of s, ds, is minus 2 rho d rho. Okay, so let's just drop this in and see what we get. When rho is 0, s is 0. When rho is plus infinity, s is minus infinity. Okay, so this is e to the plus alpha s. Okay. Rho d rho, that is, I've got that in the ds. And the ds has the 2, which we had before, and now we need a minus, so minus pi. Okay, maybe we're getting somewhere now. I'm pretty sure this is an elementary integral, e to the plus alpha s. That is minus pi over alpha, all right? That is pi over alpha. So I squared is pi over alpha. We're almost there. So just take a step back. We started off with this really horrible looking integral over the entire x-axis. And now we've got something related to it that is actually a finite number, quantity, pi over alpha. It's I squared. What we really want is I, so we take the square root. Boom. So this is our answer. This integral is the square root of pi over alpha. So that's it for today's micro tutoring session from Prep Plus. Prep Plus is your online solution for customized tutoring in math and physics for high school and college. I'm Rodney Green, the president of Prep Plus, and I invite you to contact me to schedule a free consultation. Check out the website, prepplusinc.com.